So now let's talk about the simulation itself. So as you might imagine, it's going to be another dot network over here. And you might also guess whitewater sim, like so. And we'll go in here. Very simple setup. Whitewater object, whitewater solver. Interestingly, unlike the liquid sim, we don't need a gravity node. The whitewater solver has gravity built in, so don't make another one. So that's a fun little gotcha. Get in there. We also want to copy this static object over. Can I try that again? We also want to copy the static object over. There it goes. The reason why is because the whitewater could still collide with it. Now, for the most part, it's being moved along with the velocity fields, which already account for the collisions. But you can have the whitewater not follow it as much or have additional forces, and especially the spraying. When particles can leave the surface, they'll need to collide. So just copy it over and make sure this merge is still set to mutual. Okay. So let's set it up. So the whitewater object doesn't really have much going on. It has visualizations. Turn the repellents on. I'll explain what they are in a second. Otherwise, it's fine the way it is. And the whitewater solver has the emission stuff on it. So once again, we're not using volume source or anything, which would seem like what you would use, but it's not. So go to the liquid cache. We're going to need this again, the liquid sim. So volume source means that. It doesn't mean the emission that we just came up with. It means this. If you hold your mouse over it, it says liquid's velocity in sign distance fields. Hey, sign distance fields, you know what that is for the solver. Once again, we don't need to do import volumes. This is only for a visualization thing. Don't waste your time with it. So the whitewater scale and voxel size. The whitewater scale, we don't need to tie this back to our liquid sim. You might be tempted to do that, to say, hey, our whitewater should get more high resolution when our liquid sim does. Not necessarily. The whitewater is easier to solve in general, so you can go pretty high on it right off the bat. This will be up to you. The main thing being that this should be at least twice as large as the whitewater scale. I like to just go with twice as large. So paste that reference there and make it ×2. By making the voxel size smaller, essentially, we'll be able to get some more detail out of it. So like that. As for the whitewater scale, I'm going to go down to like 0.01 here. Turn on add state attributes. This is like before when we said turn on vorticity and the rest attributes. This is something that's not going to affect the sim, nor are we really going to talk about too much right now, other than to say it stores the state of the particle, meaning are you deep in the liquid, then you're a bubble. Are you on the surface, then you're foam. And most importantly, are you airborne, then you're spray. We're going to want to isolate those spray particles later on and then render them separately. We don't want the foam to be flying in the air. We want little particles of water to fly into the air. So there's a lot of stuff on here. I mean, most of it you don't really need to change. It's a lot of like ramps to ramp in things that you probably don't really care about. But emission source is, of course, pretty important. So go to the whitewater source that we just came up with. Put this here. And one more little secret gotcha, and I'm going to turn the simulations back on, actually, is the limits. We need this to actually reflect where our sim is. I mean, by default, it's 10 by 10 by 10. I don't even see it, but it's what it is. I would say, in generally speaking, this is the one thing that we do want to copy from our liquid sim. So under the volume limits, just copy those over here. Oops. We want to copy the whole thing. There we go. There you go. So now we can be assured that we're going to have a box in our whitewater sim will encompass exactly what we need it to encompass. Okay. So that should do something. If we were to press play here, we can see it's making particles. Now, a lot of this time that it's taking to run this sim is really just reading back the liquid simulation cache. If you wanted to, you could take this opportunity to do a lower res initial liquid sim for the sake of learning how to do whitewater and getting these results faster. But I think this is going to be well enough. So again, to reiterate, it's not really the whitewater solver that's taking this time. It's reading the cache files, and that's taking a long time from the liquid sim. Okay, so we got something here. I noticed there's a lot of whitewater at the top and the bottom, and that's because of the boundary layer business. If we look at our source here, we'll see that that's there too. So I would say we know essentially that we want most of our whitewater to be coming around that rock. So I'm going to take the opportunity and say, let's just exclude these areas because I know that I'm not interested in them. So let's go say, remember that box from earlier, back when we were doing the liquid source? We made this box. Let's go grab that box. I'm going to put in a little null here, and I'm going to call it, hey, another siren, that box. Put it here. So this box, I can turn this into a volume, VDB from polygons. Why don't I see it? Here it is. This will make yet another sign distance field. Who cares what the resolution is? Just plug it into this emission mask right here. And now on the, I can turn this emission mask on here and name it, and then you'll see, well, we have the opposite of it, apparently. We could either invert this, or we can just turn this into a density volume instead. There you go. So there you go. So we knocked out at least most of that stuff. I can still see there is some over there, so I'm just going to finish this off. We might as well. It would have been nice if we could have just used this, but that's fine. I'll just literally select this primitive, just move it up. There you go. Good enough. And there you go. So now we're only going to have it in areas that are relevant to us. Easy enough. So let's come back and take a look. Now that we know the whitewater works, and we know that we've knocked out that problem, let's take a stroll, if you will, through the whitewater solver and see what's here. Lots of menus and submenus. This one's one of the more important ones that's hidden under this advanced thing. Given that there's different kinds of foam in whitewater, you know, we're doing a river. This isn't ocean foam. Ocean foam is foam that's like, it's big, it's fluffy, it lasts for hours. Like literally, if you've gone to the beach, you might see foam on the beach and it just sits there. You know, that's because there's like organic matter, like marine stuff that I don't fully understand. But when you see whitewater from a river, it's more just like, oh, there's some froth, some air got trapped in the water for a moment and it quickly dissipates. The point being that in order for this to feel right, we want this whitewater to disappear pretty fast. So, aging rates. We have a lifespan that says they should shoot to last about 5 seconds long. I was about to say, let's have that to 2.5. So the particles that get spawned will die after 2.5 seconds. Or will they? This is not a hard and fast rule. It's just going to be the average lifespan of the particles. Lots of things will control whether they last longer or die faster. For example, if we were to jump right over to foam, we'll come back and go to enable erosion. Enable erosion says if there is an island, like a big floating mass of particles, kill the ones on the outside faster and preserve the life of the ones on the inside longer, which is pretty cool. That simulates the idea that the bubbles on the outside will pop first and will kind of decay from the outside in. Or at least if there are particle or bubbles on the inside that are popping, they'll kind of collapse on each other. So it'll still just seem like the island is just getting smaller. So that is an example of how it would want to preserve the life of particles on the inside longer, perhaps even after the 2.5 seconds. On the other hand, I might want just the foam ones to die faster, which is kind of what I was talking about. I want everything to die fairly quickly. The spray can stay alive because those are just water droplets in the air. The bubbles we're not even going to see that much anyway because of how dark our liquid is and just the nature of what we're doing here. But the foam, the aging rate to 10 means age faster, meaning you are weighted towards dying at your lifespan faster. We can turn on some velocity noise just to feel like we're doing something. This is just going to move it around a little bit. This is the kind of thing I'm talking about where normally the particles are following the velocity field, but this will add some stuff on top of that. Just, that could be like air currents. Because the foam is sitting on top of the liquid, it's interacting with the air a little bit also. So perhaps it's being pushed around a little bit by that. The limits we did. Forces, like I said, gravity is here already. Buoyancy for the bubbles that are below the surface. Foam, we do want it to clump. It's going to do that by default. Erosion, we just talked about. Now, repellents is interesting. Repellents, I'm going to save. Repellents are these fake forces that basically break up the particles. So see these spheres that just got created? In fact, I'm going to cancel this. I'm going to hide this other stuff. Or I guess I have to turn this off. So repellents are these spheres that get created, and what they do is they push particles away from themselves. You can see that happening here already. Now, the more there are, the more breakup you'll get. So it just depends on the scale of your scene and how much breakup you want to see. The old whitewater had a tendency of just clumping all up together and kind of collapsing in on itself. So this is a really cool way of introducing arbitrary breakup caused by who knows what. Again, we're just grasping at straws, as they say. We are trying to come up with a solution that makes whitewater kind of look cool. We're trying to simulate millions of air bubbles that interact in ways that we can't really accurately, or we can't easily model. So instead, the whitewater solver is a combination of we observe this behavior in whitewater and we're going to try to emulate it through some novel means. But we're not really, simulating bubbles that are literally sticking together through surface tension and stuff. So we have lots of stuff like this. So repellents is something that tries to introduce some interesting visual look to it. This is especially important for boat wakes. Boat wakes tend to break up on their own too, but would normally just stay clumped together. So I like to use repellents. I think they're really cool. That's what this visualization is that we turned on the whitewater thing. Yeah. So this is all pretty good. I'm gonna say we're probably gonna want more of these because we're getting it. It's all kind of in a big mass here. As usual, there's no right answer. I'm gonna say we could go down probably quite a bit here to a tenth of this. By making the features smaller, it's going to make more repellents. And I'll make this like that. So now, if we were to look at that, you're going to see a lot more repellents. Oop, there we go. So they just get much more breakup, which I just think will look more interesting, especially at this scale. Yeah. So that's cool. The shape that it repels is a sphere by default, like a circle, well, a sphere by default. You can have this noise, though, which is here 0 to 1, where they'll have different shape repellents around them. You can look in the help card to see what those shapes are. They kind of look like a peanut, I would call it. What we can do here is with the frequency range, we can have it cycle through different shapes. No, it's not working right now. I never really understood why this happens. How hard can it be to have a help card come up? I don't understand that. Point is, that's what you got me for. So this will cycle through every half second. It'll just change the shape of the repelling force around the repellent. The adhesion is just to kind of help it stick to the surface of the water and not get pushed down into it too easily. If it is, it becomes bubbles. If it goes out, it becomes spray. By default, this uses OpenCL. You might as well keep that one on. Great. So that's the sim in a nutshell. Now let's go cache it and set up a whole and set up a way to actually turn those back into volumes.